are looking at inequalities in triangles. So first off, we're going to compare angles and sides of triangles. What this first one says is that if you know that the length of AB is greater than length of BC, so AB is longer than BC, that means that you know that the angle across from AB, which is angle C, so the measure of angle C is greater than the measure across of the angle across from BC, which is angle A. So the measure of angle C is greater than the measure of angle A. We know the converse of that is true as well. So if angle Z, which is this angle down here, is our larger angle compared to angle Y, that means the side across from angle Z, which is XY, is going to be greater than the side across from angle Y, which is segment XZ. On our next examples, that's what we want to do. We want to compare our sides from smallest to largest, and then compare our angles. So our smallest side was GJ, middle side is GH, and longest side is HJ. The angle across from our smallest side is angle H. Angle across from our middle length side is angle J. And the angle across from our largest side is angle G. On our next one, we need to compare our angles first, so we need to find the missing angle in our triangle. Remember, to find your missing angle in your triangle, you add the two angles that you know together. And then you subtract that from 180. Which gives us 87 degrees here. And then we need to compare our angles. Our smallest angle is angle L. Our middle-sized angle is angle K. And our largest angle is angle M. So across from angle L is KM. Across from angle K is LM. And across from angle M is KL. Then we have the triangle inequality theorem, which says that any two sides added together have to be greater than the third side. What you really have to check is the two short sides have to add and be greater than the longest side. So on the next couple problems, make sure that you are adding your smallest numbers together and check and see that it is greater than the largest number. If it is, you have a triangle. If it's not, you don't have a triangle. So on this one, our smallest numbers are 3 and 5. We're going to add those together and see if it's greater than 7. 3 plus 5 is 8, and 8 is greater than 7. So this can be a triangle. On our next one, our two smallest numbers are 4 and 6.5. So we're going to add those together and see if it's greater than 11. 6.5 plus 4 is 10.5. 10.5 is not greater than 11, so this cannot be a triangle. And then on our next one, our two smallest numbers are 3 and 3, so we're going to add those together, see if it's greater than 6. And 3 plus 3 is 6. 6 is not greater than 6. So again, this cannot be a triangle. On the next one, the lengths of two sides of the triangle are 6 centimeters and 11 centimeters. We want to find the range of possible lengths for the third side. So when you have a range, you have a lower number, less than x, less than a higher number. That's what a range is going to look like in this class. So we need to find the lower number first, and that means we're going to subtract 11 minus 6, and that gives us 5. So our lower number is 5 centimeters. And then we need to add the two numbers that were given together. 11 plus 6 is 17 centimeters. And that gives us our higher number. So our range is 5 centimeters is less than x, which is less than 17 centimeters. Next up, we are comparing angles and sides in two triangles. You have to have two sides that are congruent in order to do this, and then you can compare your last side and the angle that's being made by the two sides that are congruent. So in this, it says that angle A is greater than angle D. So angle A is the larger angle comparison to angle D. That means that the side across from angle A, which is BC, is larger than the side that's across from angle D, which is EF. So the length of BC is greater than the length of EF. We know that the converse of this is true as well. Our next one says that the length of GH is greater than the length of KL. So that means that the angle that's across from GH, which is angle J, is greater than the angle that's measure of the angle that's across from KL, which is angle M. So angle J's measure is greater than the measure of angle M. So that's what we're going to do on our next set of examples. We want to compare the measure of angle PQS and the measure of angle RQS. So the measure of angle PQS is dealing with that 5.3, and the measure of angle RQS is dealing with that 5.1, which of those is larger? 5.3 is larger, which means that angle PQS is the larger angle, and angle PQS is greater than the measure of angle RQS. On the next one, we're comparing the lengths of KL and MN. And KL is across from 53 degrees, and MN is across from 57 degrees. 57 degrees is the larger angle, meaning the side across from it is larger, and MN is larger. So that means that KL is less than MN. Our next one, we want a range of values for angle Z. Again, remember that a range, you're going to have a lower number is less than X is less than a higher number. And we have information in angles. So this goes with the 24, and the 45 is across from the 25. And that means that the 45 degrees is the larger angle, and 6z minus 3 is less than 45 degrees. So this sets us up to find our upper value. We need to find our lower value at the same time. Every time, the left-hand side is going to be 0, because in order to be a side or an angle, it has to be greater than 0. Then we're going to solve like we would any other problem. We're going to add 3 to all of the different parts. So 3 is less than 6z, which is less than 48. And then we're going to divide by 6 on all 3 parts. That gets us 1/2 is less than z, which is less than 8. And that is our answer. And our last problem on the notes, the angle of the swings in a circular swing ride changes with the speed of the ride. Which rider is farther from the base of the swing tower? So we know that the tower itself is congruent and the length of that rope is congruent. What's changing is our angle measure here and this distance down here. And angle B, the angle on B is larger, which means that rider B is further away from the tower.